It's okay.
Right,
it's okay.
Hey guys, welcome to our first meeting for this semester. We have a great presentation by super cool guy, Dallas came in. All right. There's a brief networking problem with the interactive demo that we have set up for you, but I'm gonna go fix that right now, and hopefully I'll have an IP address for you to SSH into in a little bit. So sit tight. I'll let Dallas take away the presentation. Hopefully it won't mess it up too much.
No, it should be fine. Right. Should be fine. Hey guys, what's up? I'm Dallas, otherwise known as Pinball Wizard. If you ever get on IRC, that is my name. That's who I am. So, you know, I just came up with that name one time, thought it was cool. Let's get into it. All right. So when talking about memory corruption attacks, it's best to know, like, at the basic level what we're starting with. So another word for memory corruption is buffer overflows. So the logical first place to start is defining what a buffer is. Now, this is pretty obvious, but when I first started learning about this, I had no idea what they were. So somebody had to explain it to me. So basically, a buffer is any temporary storage area in memory that you're going to like write a bunch of stuff to, do some processing on it, and so forth. In C, yeah, it's when you call malloc and you get this big empty array of memory and you want to write stuff to it. That's what a buffer is. Now you know. So how do we use these in a buffer overflow attack to do several different things. A buffer overflow attack is basically it exploits the fact that C doesn't do any bounds checking on any memory copies in a bunch of library functions like string copy, mem copy, stuff like that. There are many different types of overflow attacks, not necessarily just your standard like fit a bunch of stuff into one array and then have it break the program. There's a bunch of other things like involving the free call in C++, format strings, good stuff like that. Now the core principle behind all of these attacks are all pretty much the same, though. They cause a program to behave in an unintended way that it originally was.
What's the password?
Trust no one. Like 1 as the number.
Wow.
It's clever that way. All right. Anyway. So. Yes, all an attacker needs in order to exploit a buffer overflow is a memory write, he knows where it's going to be written to, and then he also needs to control what he's going to put there. Basically, those two things are going to allow him to take control of an arbitrary program and have it do whatever he wants it to do. And that's sort of the cool stuff behind buffer overflow attacks. Now, these are used like all the time. Basically, any sort of big worm that you have heard about uses a buffer overflow in order to propagate. It will scan machines looking for vulnerable services, and basically it's looking for any like unbounded copies that it's doing, and then it's just going to like inject a bunch of code into it, have it transfer control to the malicious program, and start going to town on it. It's pretty cool. There's a lot of video game hacks, if you ever heard about like home brewing a Wii, like, you know, putting a program on it, the bomb program, it like totally lets you start installing arbitrary software on it. It's basically because there is a buffer overflow in some of the software for the Wii, and it will let you do that. Is everything good? Yay! So what should we have them do? Manual's gonna let you know.
Did you change the password?
Nope.
Change the password. Quick.
Do you want to start it now?
You can do it, yeah, whenever. Doesn't matter.
You can make a subdomain.
198.
I kept on trying trust no one, like the word no one.
No, yeah, that's why I said 1 is in the number.
My bad.
Yeah,
Sorry,
but
the IT chair
before.
wasn't there.
Oh. Gotcha.
That should work. Let me know if that.
No, it's not 10. 1, 2, 8. I lost the game. 83, 83. Oh, shit. Getting kind of.
Do you trust us when you log in?
No, as it clearly says, trust no one. Let's see if I can.
Let's just say ITS.
You got it. Dude, wait, did you? No. Did you? And
Explain the context.
Yeah, that's what I'm doing. No, I'm just gonna let it go. All right. So when you log in, what the? No. All right. You'll see these binaries. Here. Wait. Okay. Yes. No. All right. So, check it out. So, all right, so this is the vulnerable program right here. And so basically what you're going to, if you just run it and you give it a string, it's going to call test, and test is going to do the string copy. It's going to print out the string that you gave it, and then it's going to call fail immediately, like directly after this. So it's going to finish this call, it's going to then call that. What you want it to do is you want it to call win. So do some fun magic with the string that you give it, and see if you can get it to point at the address of win, and that's how you win. So it's a pretty basic overflow. The details of which is actually, it's coming up, so I'm going to explain it in a little bit. I don't know if you want to try it until I get there or not, but it's coming. It's coming. And if anybody gets it, let me know, because that'd be cool.
And if you win, you get a clean copy of LabVIEW from 1995. LabVIEW is a local company.
Yeah, it is.
Sponsored or partnered with ComSoc multiple times in the past.
That they have. It's a great prize. Try really hard. Yes. Yes. Oh, yeah. But if you want like an easier way to do this, I also got this program. This is the exploit program. Basically, all this does is invoke the interactive program. So you can cram as, oh, that's the answer. No. No. Oh, it's gone.
Right.
You gotta save it.
Right.
Oh, time to open it.
Go, 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 go.
Time to open it.
Oh no. It's Jonah. Everybody stop. Everybody stop.
Shut it down.
Sorry, Alright, guys.
Yeah, don't.
Everyone win.